Hi, my name is Miho Mazereeuw. I'd like to thank Keiji Yano-san and the MIT Industrial Liaisons Program for the invitation to this event. I haven't been home to visit my parents in Kobe in about 2 years, and so I was really hoping for this event to be in person, but I'm grateful for the opportunity to share my work with you and hopefully start conversations for the future. So to introduce myself, I'm a registered architect and landscape architect in Europe, and I teach at the School of Architecture and Planning, and I am the director of the Urban Risk Lab. My approach to research on climate change and seismic risk is through innovation and design. So to describe our lab, we are action research based, and we have one side of the lab which is really based in design, in urban design, planning, landscape architecture, and architecture, whereas the other half then focuses on computer science, IoT and hardware, ethnography, human-computer interaction, and then of course, emergency managers as senior advisors. And a large part of this too is based in education. So education, of course, is for MIT and other places that I lecture, but really reaching out to different parts of the community to understand what is key in their environment is other part of the education. So we often provide workshops and maps and things that then other community members can use. Then we learn from their efforts and what their struggles are within the environment. And this we call action research. It was actually developed by a professor at the Sloan School at MIT in the 1940s, Professor Kurt Lewin. And the idea is to really include a much larger participatory approach, and then learn from those approaches, implement something, and then go back out into the field. And so we've really embraced this in our work. The other part of our work is prototyping and testing. And so we do most of the prototyping and testing within the lab. And so that way we have quick turnaround, and we can really be innovative, both in the design and the types of technology we use. And the last piece to this, beyond the field work, is then putting things out onto the street, getting public feedback, and then really improving the products that we work on and repeating the process. So within this lab called the Urban Risk Lab, we work on a number of different types of projects across many scales. Some are the larger system scale, some are built structures, and some are strategies. So I will take you through a number of these projects, but the goal in all of them is to develop these methods and technologies and prototypes to embed risk reduction and preparedness into the design of cities to increase community resilience. The first project that I'd like to share with you is called Risk Map. We've been working on this project for many years now, and it's been piloted in the US, in Indonesia, in India, in Japan, and in Thailand. And we've had a number of different sponsors and partnerships with cities that we're really grateful for. What this project does is it leverages the information that people are sharing all the time during disasters. And what it is that's different from just scraping this information off the internet is that it actually asks people to make reports through platforms that they're most comfortable with. So it's platform agnostic, it's multilingual and intuitive, and it's also multi-hazard. What the platform does is when we pick up on people talking about events within the environment, we ask them to make a report to us. So in the same way that they would be sharing information to family and friends about what areas of the city are dangerous, we ask them to share that report to us as well. Then we combine any other geospatial layers that is available, and then we have one side of this that goes to emergency managers and one side of this that goes to the public map. And the system is designed to be very easy to use, and we design each one of these cards in especially. So this particular one, for example, is a flood card deck. We ask for the location. We ask people to use this very intuitive and simple slider to show how deep the water level is, as you can see here. And then we ask for a photo, some text, and then we ask them to submit the information. Then this information immediately pops up on a public map. This was a test that we did during Typhoon Hagibis, and these are all reports around Tokyo. But this instantly comes up on the public map. And so you can alert your friends and neighbors as to what intersections are dangerous, what roads to take. And so this is very valuable information for the public. And as you can imagine, it's valuable information for the emergency managers as well. And so this is one series of this real-time map that we've been working on in many different locations. And as you can see, there are different hazards and different road closures that we're asking people to report. We took this project one step further in Kumamoto City. We did a citywide drill with them. And there we also used this and developed a new module to then coordinate between emergency shelters. And so here you can see the emergency shelters that are yellow are actually the ones that are in process of being opened. The emergency shelters that are green are the ones that are safe and open. And those that are in red are not safe and not to go to. So we also believe that this appearing on a public map is very important for the public to start to evacuate. Sometimes there's reluctancy to evacuate when the warning signs go. And we're hoping that by people being able to see through these small numbers at the bottom, how quickly the emergency shelter near their home is filling up, that they would then think, well, we should really quickly go to the emergency shelter before the one near us is full. Or if they have a choice to go into another one that's less full, they would be able to do that as well. This project also helps the coordination between the Emergency Operations Center and the people who are opening the shelters. So as our research shows that in different cities in Japan, many different types of people are in charge of the emergency shelters. Sometimes they're school principals or teachers. And so this is a very simple system that then allows them, instead of bringing a manual and a checklist, it's a chatbot system that guides them through the opening of the shelter and the coordination between them. So for example, you can imagine one person is at one door within the school meeting evacuees, where somebody else might be at another door or the gate of the school. And this system allows them to coordinate between and make requests to the Emergency Operations Center. And so this was a very successful drill that we did in Kumamoto. What the coordination allows them to do is from the Emergency Operations Center, they have the control panel, and the control panel immediately allows them to download in Excel form the timestamps, number of evacuees, and all the necessary information that then needs to go up towards other prefectural parts of the government. And so it's the whole system that's digitized through this for really this kind of real-time action. This is an example of a photo that was taken where the mayor of Kumamoto was also excited to see that this project lives online. So he could even get situational awareness from his iPad before arriving at the emergency operations center. So this whole project is really focusing on real-time information, sharing real-time information between citizens and government, but also between citizens and each other. And so the purpose is that we can all help each other through these events that happen. And much of this is already happening. It's just not happening in an organized way where everything is geotagged and shows up on a map for evacuation purposes. So we were very lucky to have funding from Line, the company, when we were working on this project in Kumamoto. And since then, I think Line and Yahoo have built a similar tool using our framework as a base. We have moved on to the next phase of the project, which is actually partnering with Google for their Google AI for social good. And with them, we have partnered also with Tsukuba University and Mercy Corps, which is an international humanitarian organization. And we learned from a lot of the emergency managers when they were working with our risk map project that when all of these different pins, information, photos, texts come in very quickly in real time, it is overwhelming. And so there's information overload from all of this information coming in at once. So what we are doing with this next phase of the project is using AI, machine learning, but not just the off-the-shelf things, but really working to crack open the black boxness of AI and input human intelligence. So for this, the first stage of the project, we have partnered with Fukujiyama City in Kyoto Prefecture. And we've specifically chose Fukujiyama City because they have been inundated with floods several times in the past. And it's a small to medium-sized city that there is a very good connection between different community groups and government groups. And so we've been able to interview many of the people of the fire department and Jishubosai Soshiki and many different community groups, including high school students along the way. So we have a very clear and holistic picture of all the actors during this moment of crisis, whenever that should happen. And they've been very helpful in participating with the kind of workshops we've been doing, where we take the machine learning, we open it up so that we can then interject with it, into it, the human intelligence component. So all the intuitive knowledge that the emergency managers have and the understanding of their locality then gets inputted into the machine learning process as well. And so this is a project that has been ongoing for about a year, but I would love to speak to anybody who has interested in this. We're not allowed to share the outcomes of it, of course, until the report comes out, but I'm happy to talk about this part of the project further with anyone who is interested. Now, because we have this real-time technology that we've developed, for the longest time, we were really only focusing on natural disasters. But of course, there are many different kinds of disasters and many different kinds of real-time information that's necessary. And something that we are all suffering through right now, of course, is COVID. And so in Thailand, this project has several different phases. One is for the risk map itself, which is also about flooding and earthquakes in certain areas of the country. But the other part is vaccine map. And so this is a project that we've been working in Chiang Mai in Thailand. And vaccine map uses a similar kind of software that we've developed, but it's a new module on top of that. And again, there is a public map, because for us in the lab, it's very important to connect the government with the public and make sure that efforts are going in both directions. And if we can be a conduit for that, or if the technology can be a conduit for that, then we think that's the best fit. So in this particular one, Thailand has several different ways to get a vaccine. One is, of course, to make an appointment, but the other is that they are accepting walk-ins, but nobody wants to wait in a long line for a walk-in, and nobody wants to show up when there are no vaccines available. And so this system is the similar kind of public map, which shows vaccines that are available. Yellow shows when vaccines are almost out, and red shows when there are no doses left for the vaccines. So the way that this works is a similar kind of chatbot system where you're guided through a process and you do not need to figure out yourself how to go through this. Everything is meant to be very easy and intuitive. And when the posts are made, it immediately goes on to this public map that people can look at to see if it's convenient for them to then be able to go pick up a vaccine. So all of these projects together, we really try to think about reducing risk together. And it's really about also increasing awareness and having people participate in the process. So yes, we can have sensors that are built into lamp posts and water gauges. And so there can be sensors everywhere. And we definitely think the combination of human sensors, so people also reporting in combination with those other sensors, is the best. Because when people report, then they are then much more aware of their surroundings as well. And they also have an opportunity to act upon that information. And they have the opportunity to share more qualitative information. So whereas a sensor will only give you the kind of information that it is programmed for, a person can give you far more qualitative information about what's happening around you. So we really believe in the combination of these two pieces. This next project, we have built a new module on top of this as well, and it's really looking at porosity of buildings in flood zones. And so for this project, we have been working with the Office of Sustainability at MIT. And I'm not sure how many people would know, but actually MIT was built on a former marshland. And so when Cambridge did its flood studies, MIT also needed to do its flood studies. So we use the same model, modeling software that Cambridge used, and we found different degrees of flood probability within Cambridge. And of course, we want to protect our university. And so we have been working on how then we can do retrofits and protect our buildings. But what's interesting about the software that then calculates this flooding is that it expects that all buildings are solids, so that they're solid volumes. But we all know that there are windows, there are grates, there are doors, and many of them are close to or below the ground surface. And so we gathered a group of students, and we measured from the Cambridge datum line, so the height that Cambridge is based, and we pinpointed where all the datum points are. And then again, we created a small little platform, which then allows students and many of us in the lab to very easily attach information to these points of porosity. So understanding when it floods, to what degree will the buildings get damaged? And so we went through and documented with a group of students and this very simple little platform that we created, how we can document all of the porosities within the buildings around MIT. So where is it vulnerable? And for that project, we categorized the openings based on material, based on age of opening, based on type of opening, and location of opening, size of opening, and of course, height of opening. So for this, what we called a porosity hunt, which was actually quite fun for 3 days, we collected about 1,000 data points over 42 buildings and looked for the different kinds of conditions that the openings were in. And then this information now gets reinserted into the flood model. So then the flood model would know what parts of what buildings, especially in the basements, would start flooding first and where the floodwaters would go. And so I know in Japan, many of the commercial activity, much of that happens in basement levels, and many cities are connected through the underground. At MIT, there is HVAC systems, labs, some student resident halls have community rooms and even student rooms in the basements. And so this is a campus-wide study to really understand beyond the flood modeling of the area, what kind of damage would happen within the buildings. And when the basements are connected, how would that water flow from one part to another? And so this has been a really important study for MIT. And we've been asked to potentially do it in different locations as well. And we're also excited to share this information and this method to other universities as well. And so this is also an ongoing project. So the projects that I've shown now are really looking at technology systems. I'd have to say that within those, though, we also really focus on design. And so the design part of those systems beyond the technology is really understanding people's behavior and understanding how design can really increase the acceptance and the use of each of those projects. This other series of projects is more built work that we've done. So for example, I would like to share the Emergency Preparedness Hub. For short, we like to call this Prep Hub. And we've been working on this in partnership with the state of Oregon in the city of Portland. But we've made these prototypes in many different places, including San Francisco and including Cambridge as well. And what this project does is it really looks at how information and power is shared after an emergency. So sometimes it's just ad hoc locations where very valuable information is shared. And so we started thinking, well, shouldn't there be specific locations that you know you need to go to if there's an emergency? And so that's exactly what this project does. It tries to activate neighborhood spaces by creating useful functions for the everyday, and then these hubs become a neighborhood focal point and power and communications distribution if there is an emergency. So this particular one that I've shown, we've made several different versions of these, but this particular one has a solar panel, a camera, information display, sound system for emergency announcements, as well as speakers for fun, and also USB charging ports and lights. So all of this could be contained into a small box perhaps, but we believe that we want to create this cognitive map where people know, because they've engaged with it before, they know where to go if something should happen. And so we've included fun elements like this bike pedaling so that people can remember where these benches are essentially. And each part of this project is really designed for this dual use. So for example, each light turns on blue as a child or somebody starts to pedal. But once there is 5% charge in the cell phone, there is a rainbow. So this is great in two purposes, because the kids especially who are on this try to race each other to see who can get the rainbow first, which just then increases the battery power. And then during a disaster, if there is a rainbow, that means that this person already has 5% charge, which is enough to make emergency phone calls. And so this dual use design, we really try to include in every part of the project. And so different versions of this that I'm showing here, again, the fabrication we do in-house, and so that we're able to test and make new elements of this. And then we've designed many different versions of this for different scales, including the largest one being Forest City Park. And so there are many elements to this that we would like to explore further. And we've also built one actually that contains the water module, and we built that for Nepal. And so beyond the US, we've also been working on this project in Nepal. So this is one example of our dual use design work projects. And it takes inspiration from some Japanese projects, which I will share later as well. The last category that I showed in the beginning is really looking at strategic planning and thinking at the national scale. For this piece, we have been very lucky to partner with the Federal Emergency Management Agency here at in the US. And for this, we have two projects that we've been working on with them, neither of which I can share that publicly, but I'm happy to talk about them further to anyone who is interested. One is designing a new temporary housing. And so for that, we have designed and built a full-scale prototype of temporary housing that is easily movable and reusable, because there is a lot of temporary housing that then remains on site. And currently the system is not reusable. So for the US, this is currently only being considered for the sites outside of the continental US. So Puerto Rico, American Samoa, and the tropical island locations. But we have been working on this project for many years, and we're excited that the prototype is now finally complete. Another piece, which actually I think would be very interesting to consider for Japan as well, is preparing for recovery of a disaster. And so we've been studying the system within the US of national level policies, how they filter down through the regions, through the states, to then the municipality. And we've also studied this in Japan as well, that it's very difficult to find ways of a one size fits all. And so what is the translation of the national policies as it moves down through the stages into actual implementable strategies at the municipality level? And so for this, although we've studied many reconstruction projects, the idea with this was to build a toolkit that actually helps this planning work before a disaster starts. And so we have been piloting this in 4 different locations now: the Boston area, Toa Baja in Puerto Rico, in Chatham County, Georgia, and in Sacramento and Yolo counties in California. And the purpose of this toolkit is to really understand what the outcomes potentially will be and to be able to prepare for them, especially housing recovery beforehand. And so I think this is something that perhaps the city of Tokyo might be interested in as well. I think that there is a lot of effort there right now, rightfully so, to prepare for the next earthquake that may happen there. I think the predictions are within the next 30 years. And so this is, again, a project that we're working on in the US, looking at national level policies, figuring out with localities how they fit before a disaster should happen so that the preparedness is there, and finding ways to mitigate and prepare in advance. Lastly, within the few moments that I have, I'd like to share a book that I've been working on really since the 1995 earthquake happened in Kobe. So it's been a lot of research, many years, many interviews, many places in Japan that I visited, over 50 case studies. But so this is my effort of not only bringing parts of MIT to Japan, but really highlighting many of the amazing projects that have happened in Japan and the learnings from all of these projects, and sharing it with the rest of the world. And so this book will be coming out this year. It's called Design Before Disaster, and it will be published by the University of Virginia Press. And the book looks at coastal strategies, many large logistics and even historical sites that are used for logistics, and also schools and other significant buildings, including tsunami evacuation towers and hotels, and how other places were used both during and preparing for different types of disasters. And so I'm hoping that the next time we see each other, I will be able to provide you with this book too, because there are numerous case studies within here that I'm taking and borrowing and learning from Japan and sharing with the rest of the world. So I think that is all the time that I have. I would really look forward to the conversation, of course, after this presentation, but also please feel free to reach out to me. Our website is risk@mit.edu, and my email address is mmaz@mit.edu. And thank you so much for your attention.